So we started off reviewing which property says that this is true. I switched the order, so that's the commutative property. And again, I just switched some order, the commutative property again. And here I did not change the order, but I switched what my -9 is associated with first. I switched the grouping symbol, so this is the associative property of addition. And remember, we use all of these to help us add mentally. If you know you can switch around the order and the groups in addition, you can make it so you can move them around and add mentally much more efficiently. So we use the integer tiles today. It's a hands-on way to see this. So we just started off. I'm just going to review with what we did. So we started off with 7 tiles on our field, and we took out 4 of them. And when we take out 4, we have 3 left. And then we started with 5, and we took out 3 because the takeaway model of subtraction is a really good model for using with integer tiles to understand subtraction. So when we take out 3, we're left with 2. And then we came to 0 minus 2, and at first there was nothing in here. So you guys put in 2 zeros. Remember, a positive and negative makes a 0. That's another 0. This still said 0, and now we can take out 2 negatives. Excuse me. Sorry, I said that wrong. We can take out 2 positives. This is subtraction, and these are the positives. So out come the positives, and the resulting answer is -2. So we take out the 2 positives, and we're left with the 2 negatives. And that's the answer to 0 minus 2, -2. And then how do we do 3 minus 5? Well, we had 3 positives in our field. We have to take out 5 of them, but we didn't have 5, so we put in 2 zeros. And then we can take out all of the 5s, and notice what we're left with is 2 negatives. So these 2 halves of the zeros have to go out. So really what we end up with is 2 negatives left over, -2. We started with 6, and all we have to do is take away 2 of these negatives. So we start with 6 negatives, out come 2 negatives, and we're left with -4. So real easy to do with the tiles. All right, then we started with -4, and we had to take out 5 negatives. We didn't have 5 negatives, so we put in a 0, and then we take out our 5, and we're left with a +1. This is -5, take away 2, and that 2 is positive, so I had 5 negatives, but I don't have any positives to take out. So I put in 2 zeros, out come the +2, and notice I'm left with 2 more negatives than I had before, so I have -7. So -5 minus 2 is -7. 2, we started with 2, and we have to take out 6 negatives. I don't have any, so I had to put in 6 zeros. Once I have my 6 zeros, taking out the negatives is like adding the 6 positives. So I end up with these 2 plus this 6, which is the other half of the zeros, because I took out the negatives, which gives me 8 positives. So really this is 2 plus 6 because of adding those halves of zeros from taking out the negatives. All right, then you did some on your group, so you had to start with -8 and take out 3 positives. So these were our zeros, out come the positives, and I have -11 left over. Here you had to start with -8 and just take out 3 negatives, and I'm left with -5. And here we started with 8 positives right here, and we have to take out 3 negatives. I don't have 3 negatives, so we put in 3 zeros. Once we take out those negatives, we're effectively adding 3 positives, and 8 and 3 is 11. We started with 8, and we just took out 3, just like you did in first grade, and we're left with 5. So I wanted you to notice the patterns here. Why are the answers all negative? Well, we started with all of these amounts of tiles, and we took away less than we had. So what we're left with, we took out 3 of these things from 8, and we're left with 5 of those same things, and they happen to be negatives. So all of these, the amount we began with, is less than what we took out. So we have a remaining amount of negatives. And in all of these, we didn't have any positives to take out. This is taking away positives. So we had to put zeros in. And when we put those zeros in and took out the positives, it really gives us 3 more negatives than what we started with. So really we're adding negative 12 and negative 8, adding negative 11 and negative 5, adding negative 7 and negative 3 to get negative 10. And in all of these, I had to take out negatives. Didn't have any. I had only 8 positives. So when I put out zeros and take out the negatives, really I'm adding 3 more positives to these 8. I'm adding 3 more positives to this 7. I'm adding 5 more positives to this 11. So that's why this becomes adding, and we get positives only because we took out all the negatives. So then you tried some. We start with 6, take away 2 negatives, and we're left with negative 4. Start with 3 positives. We have to take out 9. I don't have 9, so I have to fill in zeros. Now I take out my non-positives, and I'm just left with these 6 negatives. Start with negative 6. I have to take out 2 positives. Don't have any, so I put in 2 zeros. Notice taking out the positives really adds 2 negatives, because that's the half of the zeros that I didn't take out. So I end up with 8 negatives. Start with negative 3, and I have to take out 5 negatives. Don't have them, so I have to put in 2 zeros. And now when I take out my 5 negatives, I'm left with a positive 2. All right, so in general, the algebraic definition of subtraction. We don't have to use tiles, but what we find is this is a pattern that worked in every circumstance, in every single kind of problem, whether it's a positive minus a positive minus a negative minus a positive, or a negative minus a negative. To subtract that number, which is always that second number, you simply add its opposite. So negative 3 minus a negative 2, this becomes addition, and the opposite of negative 2 is 2. So this problem here becomes negative 3 plus 2, which is just negative 1. So you simply change it to addition. I change my subtraction, this subtraction, I change to addition, and I change y to the opposite of y. And now I have an addition problem that has the same answer. X minus y is the same answer as x plus a negative y. Okay, and we did this with addition. You guys discovered, whoa, 5 plus a negative 3 is really the same thing as 5 minus 3. And it is. All right, then you tried some with rational numbers. So first you had to get a common denominator. So in eighths, 1/2 is 4/8. And now I add the opposite. So I have 7 plus 4, 11/8, which is 1 3/8. And then another subtraction model is the change in something. And to find the change in something, you always take the later value and subtract the earlier value. So I started, my earlier value was $50, and then I spent some money. And now I only have $4 left, and I want to know the change in the amount of money I had. Well, my later value is $4. I subtract my earlier value, and what I get is a negative 46, which tells me I spent $46. That was my change, a spending of $46. We practiced translating English into mathematics. So this word looks like this symbol. Negative 9 looks like this. The opposite of t is negative t. Same thing. This is the opposite of 9. And the opposite of a negative 8 looks like this, the opposite of a negative 8. We just put in brackets so we don't have negative 8. But without the brackets, it's the same thing. And then we practice some on your slates without the tiles. So negative 3 minus a negative 2 became negative 3 plus 2, which is negative 1. Negative 3 minus 2 became negative 3 plus the opposite of 2, which is negative 2. Negative 3 and negative 2 is negative 5. 5 minus a negative 6, we add the opposite. So that becomes 5 plus 6, which is 11. 3 minus 2, we add the opposite. That becomes 3 plus a negative 2, which is 1. And 3 minus a negative 7, we add its opposite, and that becomes 3 plus 7, which is 10. And by the end of class, you all had it. So just do some practice here. Pages 297 to 299, 1 through 4 for the basic, etc., and the challenge. And have a great day.